everyone. Thank you for joining us on this webinar today. Your presenter is Ryan Vanderwerf. He's a member of the Grails and Micronaut core development team here at Object Computing. Today, Ryan will be introducing the basic technology that powers the Amazon Alexa, and he's going to demonstrate for us how to develop custom skills for your devices. He will also provide some tips and tricks for publishing skills to the marketplace. So we hope you enjoy the presentation today, and with that, I'll turn it over to you, Ryan.
Thanks, Jen. All right, so what I'm going to talk about today is how we make our own skills for Alexa and how to do that with Micronaut specifically. So I'll talk a lot about these examples of some of the basics of concepts, and then we're going to get into some examples of how that's actually done. So let's get started. A little bit about myself. Again, I'm an engineer in the Grails Micronaut team. I just tinker with gadgets like these all the time, anything from cars to talking to things or beer or wine. So let me know if you don't like this one. Maybe you could talk about some other things in another time. One place to hit me up is Twitter if you have any other questions after this presentation that you might need to get addressed. All right. All right, so we're going to talk about what is Alexa and what does it cover, how does it work, talk, why does this matter, this kind of UI. We're going to talk about the software concepts and components of the version 2 API, which is their newer one. We're going to talk about a little bit about how Lambda works with Micronaut, and then how we do set up an application through Lambda in Micronaut. And then we'll walk through some examples that we've included in our Micronaut AWS SDK. And then we'll also get into a more advanced example where we can have our little Star Wars quiz. This is something we frequently use at our booths for people to try out the technology. All right, so what is Alexa? Basically, Alexa is a cloud-based voice recognition service. So this is basically what the architecture is here. We basically say something on our device, and it will go to the Amazon Alexa service. The device doesn't really have any smarts in it, and then that's going to process whatever you're saying and then send you a response back in two forms. One is it will talk to you, and the second is it will send you a card, which is a visual response that will appear in your Alexa app. So if you install the Alexa app on Apple or Android, you'll always see a card come back along with the response as well. It's a good way to know if it triggered erroneously to find out what it thought you said. These are the devices, so we've kind of evolved, right? We've got 3 different evolutions now of these. It started out with the original Echo version 1, and there was a version 1 Plus, a version 2, and a version 2 Plus. These are all these kinds of things Alexa can do, right? Just general life enhancement things. What's the weather tomorrow? How many teaspoons are in a tablespoon? No one can ever remember that. You can have a shopping list, add to your shopping list. There's an API for that too. You could ask just general questions. If you search for things that are general things, it will look on Wikipedia for the data. It doesn't actually search Google. That's one thing the Google Home has over this, is that it can search Google for things, which could be good or bad. This is what it looks like inside, so it's pretty neat. Again, it's kind of like they almost be called like a bent pipe, really. It's just enough of a Linux OS to boot up and listen for the wake word, and then send all of the speech data files to Amazon for their whole cloud to process. And that's why I can do things so quickly, because there's not enough hardware in this thing to actually decode every bit of English speech or Spanish or whatever language you're in. It supports multiple languages now. That would be not very practical to build into a device. So it's just enough to upload all that stuff to the cloud, and then all of the services that Amazon does individually now, like Lex and things like that, will process all that information. Here's a little bit more about inside of it. This is the original version 1. It had a little subwoofer. Again, it just, what makes these things work so good is it has this 7 microphone array. Almost all of them have these 7 mics here, right? So if you put this in the middle of a room and it hears a noise, it's going to focus in on wherever the noise is coming from, and then mute all of the other microphones around it here. And then, like, if it's right here, then it's going to turn that one on. And that's how it is able to work so much better than, say, I don't know, putting Alexa on a cell phone and then just setting it in the middle of a room. It's pretty good about overhearing noise. And it also has noise cancellation built in. So when it's playing something, it can cancel its own noise out and it won't block it from you being able to give it commands. All right, so the original version 1 of the Echo, we'll go over that a little bit here. It's a nice speaker. It's got, Wi-Fi, Bluetooth, all these simple capabilities. It doesn't have any kind of auxiliary output. It was something they really kind of missed. They've added in a later version. So when they created the Echo Dot, really the purpose of this thing was to add a 3.5 millimeter audio out. So you could hook it up to your stereo or something. And again, same thing. There's 2 different iterations. There was actually one with buttons on the top, and there's another one that had a ring on the top. And then the current generation, which is the nice fabric looking, much sleeker. The sound is a bit better too, because it's got that nice cloth speaker grill around it. And they're very cheap. Frequently, these things are on sale for, I just saw a 3-pack of them the other day for $60 or something. So they're really inexpensive. And here's what one is inside. Again, it's pretty simple. This is actually the original one. They're a little more compact now. Then we've got this thing called the Tap. It's a portable Bluetooth speaker. You used to have to tap it, but you can actually, after a firmware update that they put out, it can actually be left always on in battery mode. You just understand the caveat that eventually the battery will run out and then it'll just be dead. But this works as like a portable Bluetooth speaker. It has an audio jack on it, but it's only for input to use as a speaker, not the reverse like on the Dot. All right. And then here's another one that's interesting that I don't think really took off. I actually bought one of these on clearance the other day for 25 bucks. It gives you fashion advice. So it's got a camera and a microphone in it, and it'll take a picture of you wearing an outfit, and a fashion advisor will tell you what they think about that outfit. So I think they're targeting this a little more towards a fashion-oriented audience. Originally, it was $200, which seemed a bit steep. If you get it really cheap, though, it actually works pretty good as just a web video camera. So you might check that out if you see a deal on one. And there's other things too, right? So people always forget about other Alexa devices. There's the Fire TV. People have a lot of those around their house hooked to their television. Well, it's got all the Alexa stuff in it too. A lot of the remotes have a microphone on them to talk to Alexa. So when you're making these skills, they're gonna work on all of these devices around your house. Anything tied to your Amazon account, when you publish a skill, is getting to work. Whether it's public or not, you can make things for just around the house if you want. And don't ever share them with anyone. One thing you can't do is you can't do the alarm function on the Fire TV. I guess because your TV would probably be off when it goes off. So it's the only thing I found. And they got the Echo Show. So now we've got graphics. So now I'll show you some examples of this. Now you can do graphical layouts. So not only are you giving cards back and text, but you're giving graphics. So you do things like this weather deal here are all part of the layouts that you can send back to it. And the new SDK gives you a much richer selection of things you can do to do some simple layouts of graphics and fonts and things like that to make it look, take your skill to really the next level. We've got our visual layouts. They also came out with a version 5. I don't know, they skipped a bunch of ones, but 5 just means 5-inch, and it's something that's very inexpensive show. Just came out, it's less than $100. Something you might want to look into if you want something inexpensive. You could also find the old original Echo shows for really cheap on clearance. The sound's pretty decent on them too. And they have camera for video chatting and things like that. Then we've got an Echo Spot. I have one of these. I use this on my nightstand as an alarm clock. It actually has a video chat ability, but it's a really tiny screen. So you really wouldn't be, watching videos on this or anything. It's just kind of a nice alarm clock function. And what's cool is if it loses internet, your alarm's still going to go off because the alarm function is local. Could be important if your power goes off overnight or something like that. They have a new one called Echo Input. It has no speaker on it whatsoever. It is just the microphones. So you plug that into your stereo, and that's all there is to it. It's the cheapest possible way in. Might tie with a Fire Stick, like a basic one, but it's the cheapest way to get into an Alexa, other than just running the Alexa app on your phone. Technically, that's free. Talk about some other new cool things here. They got these things called Alexa gadgets. These are Bluetooth devices that pair up with your Echo device. And there's an API for it you can use to make skills that interact with these things. And it's something you can turn on in the developer console. I'm gonna show you where you turn that on. We're not gonna go over really making skills with these, just yet because I think that would be a lecture in itself. But just let you know about these. One of these I have is this alarm clock where it pairs to your device. And so at each one of these tick markers go down, your timer is a minute. And then spaced out ticker might mean an hour. So looking at this, it might say, there's about an hour and 10 minutes left on something before the timer goes off. And then they also have these buttons. They change colors. So you can do like a Simon Says game. You can make Alexa games. And so you can actually make a decent amount of money on the store for these things, where you can charge for them or charge for upgraded abilities on these, where people play trivia games and things like that, where they got to hit the buzzer. Works really well for that. You can have up to 6 of them paired on the device. So you can kind of use it like a party game. And there's all kinds of other stuff too. And again, they don't have a microphone or speaker. They're just gadgets tied into the device that you can interact with. And you can't interact with them directly, right? You have to use the API. There's no way for you to get to the hardware level of Bluetooth and mess around with these things. But they've got a microwave now. You could say, Alexa, pop my popcorn. They've got a Billy Mouth Bass, dancing robots, Christmas lights, things like that. So anyway, I'll give you the link to dive into that some more. And they got some other devices here from other vendors. Google Home is the nearest competitor to this. There's also a Facebook Portal, Apple HomePod, something called Ling Long Ding Dong, which is for the China market. It only understands Cantonese or Mandarin, depending on which one you buy. So there's definitely, I think, catching on, right? Amazon kind of started this, but now everyone's doing it. All right, you can make your own too. A lot of people say, I don't trust this thing. It's full of nefarious spying things, which has mostly been proven false. But if you don't trust it, you can make your own with a Raspberry Pi and a microphone and then watch what it's doing. You can grab the code here and put it on a Raspberry Pi, hook a microphone up, and make your own little Alexa with their AVS kit. So it's a different kind of SDK meant for hardware developers. So if you want to make a dishwasher that's Alexa enabled or whatever, you can use this kit to enable that and join their partner program and get going on it. All right, so let's get into the guts here. How do we make these things? So how do they work, right? So key point here is that a developer never talks directly to someone's Echo device in their house. It never, ever happens. You're only ever talking to the Alexa cloud service running on Amazon. And then Amazon reaches out and then we'll talk to your Echo device, right? So if I've got an Echo device in my house, it's only ever going to talk to Amazon's cloud, not to some third-party developer's system. The Alexa cloud will then reach out, call my third-party system, aka my skill, and then send a payload to it, which will be in JSON, and then we're going to send a payload back to it in JSON through the SDK, and then that's going to go back to the user, and then their device is going to say it or visualize it or both. One of the rules is, and there's some exceptions to these, but as far as the SDK goes, there's really no exception. The user must initiate the interaction. You can't just say, turn on some Echo's device and start screaming. That would freak people out. They don't allow that. There's exceptions to this, which are only Amazon can access them. And those are things like drop-in features where you can yell upstairs and tell your kid to take out the garbage, or do an announcement at the house saying dinner's ready. Those kind of things can be uninitiated, and they're only at the local level, and they're only specifically at the Amazon. Third-party people really don't have access to use those things. So that's another thing to keep in mind when you're thinking of a use case for a skill. It can't just say, oh, an hour from now, do something on their speaker. That's not going to work. Again, we process all of these things with a JSON response and request. It takes text-to-speech. We can do small sound clips via MP3s. We can do video now. We can also do music and sound files, and we can make a skill that does nothing but audio playback. An example of that is the Groovy podcast skill that you can find published out there. So that is a thing I wrote in Grails a while back, but it basically reads the Podbean RSS feed and then will play any Groovy podcast version that you want. And it's using that through the audio SDK features. Currently, when you're using this with Micronaut, really Lambda functions or functions in Micronaut are the only supported mechanism. There is no support currently for doing this through just a controller and a stood up web app in a traditional sense. I think that's something that was maybe added in the future, but that's not something it does currently. So right now it's just strictly Lambdas, which is fine because Micronaut boots up really quickly. You shouldn't find that to be a huge problem. All right, so here's kind of how they work, right? So again, we're sending a device, conversation to the Alexa service. That will then figure out what intent you mean and what invocation word for an application. And then it's going to send that to the developer app and says, okay, they ran this intent to your application with this data. It's up to you to process the data and then create some sort of response that makes sense back to the user. And it can be in one of two things. It can be a tell response, which means it just says something and it's done. It's the end of the interaction. Or it could continue a conversation, which is an ask response, right? So everything it says, it's going to ask for something in return. And then you can have these nested intents to have a whole conversation in an application. And I'll show you how that works here in the developer console. Just a bit here. All right, let's talk about why this matters. I'm just going to go over this fairly quickly, but we've had all these UIs evolve over the years, and why does this matter, right? And so we started with computers with character-based interfaces, green screens. Then we go to the GUIs, right? And the first even Apple GUI, and then Windows. And then we went to web interfaces, the Mosaic. Then we went to mobile interfaces, where we do these, gestures and pinch zooms and all these things, right? We get more and more information. And now we're at the point where we have this voice user interface thing. This is really great for people that aren't computer savvy. They'd rather talk to something in plain words than, and I would say English because maybe speaking another language. But and if you're like disabled, if you have some kind of disability, this thing can make a huge difference in someone's life. I personally and my parents have something where they can call for help if they fall down or something and they don't have their phone on them. And that costs nothing. And these things are cheap to place around. So there's just a lot of things you can do, or simply turning the lights off because you don't have to get up. If you have a disability, that all those things are a lot of work to do every day and to make people's lives a lot better. So that's why we care. So I'll just gloss over these here about how here's all the thing. I don't know if we could ask this later. How many people remember this one? What system is this from? And we go to Mosaic. And we go to the mobile, a little bit less information, but we've got gestures, more interactive things, and now we're at our voice things. And speaking patterns are complex, many ways of saying the same thing. That's the trick of this stuff, right? So before all this cloud AI stuff that could kind of get the gist of what you mean, before it was pretty obtuse, right? If you didn't say exactly what it wanted, it would not understand you at all, and that would get super frustrating. And so now we have things called sample utterances that they use to train a model, and then that will if you give it enough information, it'll be able to gist other things people say that are similar without saying it exactly, and your skill will work. And that's the magic that makes this thing not frustrating to use, or not as frustrating to use. All right, so we're going to talk about the custom skills SDK, but there's other SDKs available here. I don't want to exclude all of them because you can do different things. There's Flash Briefing SDK, which is really like pointing it to an RSS feed. So if you say, give me my flash briefing in the morning, it will tell you the news and things. Those are flash briefings, and they're really just RSS feeds that it will read information. So you can customize an RSS feed for someone and through server-side code, and then tailor that RSS feed to be Ryan's feed or whatever I want to hear about, and it'll basically read the news to you. We've got Smart Home SDK, which only works with Lambdas. We've got a music SDK, or audio really. There's a specific one for making just video apps. And they have a baby activity SDK now. So if you want to make things to track your baby in the crib, you can do some interesting things there. I haven't delved into that personally, but it is there. And again, another one we're not talking about is the voice SDK, right? This is how to build a hardware device that embeds Alexa in it, or Alexa support. That's part of the voice SDK. We're going to be really focusing on the custom skills SDK with Micronaut today. All right, again, we host this as a Lambda function, and really what's happening is it's taking a JSON request, parsing it, and then making some sense of it into intents, and then we're going to send it back as JSON, and it's going to say something or visualize something, and have a card as well. And the new Java SDK, they completely rewritten it. So if anyone's used my Grails SDK stuff before, it was a bit dicey, and they've put a real honest effort into making a better Java SDK that's builder-based, and I'll show you that. It works a lot better, and it's kind of easier to find things. And what does this SDK do for you? For one thing, it validates the request. It'll automatically handle the envelope with the encrypted signature and validate that. It'll automatically check that the skill ID matches. So every time you make a skill, you get a unique identifier. So if you get a request coming in, if it doesn't match the skill ID, you can throw it away. So you can separate people tampering with your application versus real requests from Alexa. Because there's really no whitelist IP address you can do. And it really builds us these audio and video card responses. All right, so let's dig into the specifics here. So we have to describe intents and slots. And so when you upload your utterances, Alexa calculates speech variation. So let's take a look at what one of these files looks like. And I'm going to pull up the console here. This is the Alexa developer console, and I've got a whole bunch of stuff here. So to get to this, you're going to go to developer.amazon.com, and then you click on Alexa, and it's going to take you here. And if you're just starting out, you won't have anything here. You have to make one with a create skill button. I've got a fairly fancy one here. Let's go look at this one. This is our Star Wars quiz. And you'll be able to find this in the Micronaut examples bit under the AWS project for Micronaut. All right, so we have these things called intents, and these are mapped here. So here's a answer intent. So if I want to, excuse me, I'm going to say a question, and the user says something back. How do I parse that? So I have to give it sample utterances, right? And so what this is a slot. This is like a parameter. Think of a slot as a parameter. And then we use sample utterances here. So I can just say the answer in this case, or I can say the answer is my answer. I could say, is it the answer? So I could, is it 4? I don't know. It'll take that as an answer and then tell you if you're right or wrong. We can say my answer is, the answer is. So the more clues you give it, the more it can gist what someone says. You may not have to exactly say any of these things. If you give it enough hints, it will start figuring out other speech patterns based on that. So it'll build this sort of model that does that. So, and that's how we, you can actually do this utterance profiler here and tell you how well they're working, which is really cool. It's something that is fairly new. And then we have built-in intents here. So another one I've got here is a repeat intent. So I have to say, can you repeat the question? If you say any of these things, it's going to repeat the question again. And so what's going to happen is it's going to call my Micronaut application, trigger the repeat intent. Repeat intent is going to say the question again. Go look it up in the database, pull it out, and then say it. And again, slot type, I made a custom slot type. They have their own slot types, but I just made my own here, and these are the numbers of the questions, right? So I'm going to ask you a question about Star Wars. You've got 4 choices, and you just say the number. But you can use an existing type. There's lots of different slot types that aren't even custom. Amazon has a zillion of these things. They have numbers, dates, times. They have like, over 100 of these in total, where it just knows what these things are, like names of animals, airports. And what's cool about that is it handles multiple languages for you, right? So if it's an animal in Italian or Spanish or anything else, it would know what those are, and you just use that intent in that slot, and it figures it out. Very, very nice. Stuff's come a long way. So, and I've got a link here in the slides of how all that stuff works. We can get later. All right, and then the first thing we have to do is how do you invoke the application? So this is what tells Alexa to call your application and start it up, right? So if you say, Alexa, open Micronaut Star Wars quiz with my skill invocation name, that's going to know to pull it out of my account and on that. And I don't even have to publish it. If it's on my own devices, it'll just work. Again, the slots, let's talk about those a little quick. Those are the parameters that you pass in. So if you say, I want to say my name is something, but the answer is some number, right? Those are slots, and those are basically parameters passed in. So you'll know, it'll parse those, and then you can take appropriate action for that. If it's a variable kind of response thing, it doesn't work all that well. It's something to keep in mind on how you design these things. And here's a link to all the different kind of slots too. Good reference of all of them. Definitely use those where you can. Again, I showed you the sample utterances. So this is what trains Alexa to respond. The more phrases you give it, the better. And it will try to guess speech variations. The more you give it, the better it guesses. And one tip here is always use redundant or almost misspelled words. It's okay to have 1,000 different sample utterances for something. If you want to make this thing really work well for almost any case, you can do that, and it'll pick up phonetic versions of things, stuff like that. All right, then we also have the Alexa app. So this is where we do our non-speech interactions. This is the log. You can see where it's done. Most common misconception of Alexa is that, oh, it misheard me and recorded me and spying on me. You can go to the Alexa app and figure out. Go to echo.amazon.com or your mobile app, and you can see what it thought you said. It probably just misheard a trigger word and then thought you were going to do something. And that could cause all kinds of erratic behavior if it has an unfortunate series of misinterpretations, like calling your friends or all these goofy things like that. But also see that card by return to a skill. And why cards matter is like, if you want like a URL for a website on a card, makes sense, right? But you don't want it to say HTTP//. That's really annoying. So you're going to separate your speech output. For the card, it could have things like links or hashtags, and then speech is only going to be things that would make sense to actually say out loud. You don't want to just drone on with your speech response and bore people to death where they just lose interest and cancel the whole thing out. And you can also install skills here. So once you publish a skill, you can find them. You can even pay for them now or subscribe to them. If you create a skill, it's a top performer, they'll actually just send you money. A friend of mine did that. He made a little kids game and he got a check for $1,500. So you can make money doing this. So pretty neat stuff. Again, these cards, they're kind of similar to Android cards. If you've ever done Android developments, cards can come back. It's the same kind of concept, but they're really simple. You're not allowed to put JavaScript or HTML in them, really. There's basically 3 kinds of cards, and the third one I don't even consider a card exactly. You've got simple, where it's just text. That means no markup is allowed. If you put a link, that means I'll have to cut and paste the link. You can't click on it. There's a standard card where you can attach a picture to it. And that's all you can do. And then the third kind is something called link account. And this is used for personalization. So if you want to link, say, your account to, I don't know, your Uber or whatever, right? This would authenticate, tell you need to authenticate with another service. It would use OAuth, and then get a token, log in, and then Alexa will store that token. So the next time you interact with it, it will have that token, and then you can look it up and know who they are. So this makes sense for anything personalized where you might buy something or do some interaction with a third-party service that needs to have a login. Again, our intents. So at Micronaut, we've got a few ways to do this. So we've got the intent handler annotation, or you can build a class that implements an interface that does an intent. And then we also have to add built-in intents. There's ones built into Micronaut for stop, cancel, fallback, and help. You do need to make sure you add these, though, to the developer console here so that the intents are actually sent through to your application. For example, fallback is not there by default usually. You need to just add it. And then you can have a fallback annotation. It basically means you said something, I don't know what the heck you said. I'm going to do whatever and say, hey, well, I didn't understand you. Say these were the choices or whatever you can do. Always tell them what to do. Don't assume they know, because they don't. You have to say this or say this. And that's excuse me. That's pretty much how you need to make a voice UI work. So if it's a real quick, small thing, you can just use the annotations. If you want to make a fancy thing, you can, certainly make something more advanced. Let me show you an example of a real basic one that's part of the Micronaut SDK. All right, let's take a look at this class here. So this is our basic hello world. Doesn't do much, but it gives you the layout of how to make an application. This is a good starting template to look at. Say, okay, I want to make an Alexa skill. Micronaut, how do I get started? We have this JSON deserializer here manually. You have to put that there on Java. If you're using Groovy, you don't need to. These are JSON properties that have to be mapped if you're running Java. If you're running Groovy, you don't need to. For example, we also have Kotlin example here to do it as well. So if you're using Groovy, it's much cleaner. This is all you need in there to do basic things. So it's a little more verbose than Java, but if you want to do that, that's totally fine. And really, how we do is we just need this intent handler here, right? So this @intent handler, and then the name of the intent. So you just need to make sure this word matches what you have in the developer console. So you need a hello world intent. And then it will trigger that if they say the example utterance. It will say, okay, I know you mean hello world intent. In this case, it's just going to say, you know, hello world and give you a card and goodbye. We've also got the help intent here. So if you ever say help, which is required by Amazon, you're always required to implement cancel, help, fallback. Those are all required things. If you want to get a certified skill, they'll reject you immediately if you don't have those. It needs to always stop when asked, and it always needs to have help, and it always needs to have these basic things where you'll automatically be shot down. So if you say help, you can say hello to me, and that's what it does. And then we've got here a fallback. It's just like, I don't know what you said. Try saying help in this case. And then cancel, we'll just say goodbye, right? And we're going to always terminate the session. It's done. Always what we call a tele-response. So in here, that's where we differentiate whether we're doing a response builder or a request builder. And again, here's how you tell it whether it's a tell response or not. See this with reprompt? So that means you can say something and it'll allow the prompt to allow the user to respond. And then that could be a sample utterance that will match another one of your intents, and then the conversation continues. If you don't do that, like for this example, goodbye, then that's it, it's done. The response is finished. That's all there is to it. This is quite a bit different than the way it used to work. If you've seen the older Alexa SDK, where it basically had a series, it was more of an event driven. There was a launch, session created, session stopped. All those things are different now, and not the same at all. We can also do it this way, where we implement the request handler interface, and then we just give the class the name of our sample utterance. And then we can implement a matches of, okay, does this handle this type of thing? Excuse me. And if so, it'll say yes, then it'll continue. And then we implement handle method. And then this again does some stuff, respond, and then we can continue the conversation. All right. Here we've got intents. All right, we talked about those. You can use our handler. There's other things you can do called audio player directives. So this is what the Groovy podcast uses actually. This is where it's a long running thing. It's not just a snippet of sound in the middle of your speech, which you can do with SSML, and we'll get to that. But if you want to make something that just plays, something that plays for, like, you know, Groovy podcast episodes are typically half hour to an hour, you're not going to carry on a conversation during that, right? So what's going to happen is you can queue, you can trigger these directives when you return in your response builder. You can queue it, replace anything in a queue, replace anything that currently is queued up, and then we just basically say, tack down as add audio player directive, and then we can start playing something. And it's up to you at that point to manage the state. So if you want to pause or resume, which Amazon requires you to do if you're doing audio skills, you're gonna have to restore somewhere in a database. I use DynamoDB myself, where the offset was, what the hash of the user was, and what they were playing, and then where they were at as far as like a time offset. So you need to be able to say, Alexa, pause playback, and they can come back a day from then. And then if they haven't done anything else with their Alexa and it's still going, you can say resume, and it's supposed to work. And that means it needs to pull it out of the data store somewhere, figure out the offset, figure out what they were listening to, and then start playing that again. So that's all on you to do it. The Alexa session stuff doesn't persist that long, and that won't help you. Again, we'll talk about SSML. So we can do little short audio snippets, say make a little sound effect at the beginning of our skill, or I've seen games use this where it's kind of an adventure game and you're choosing branches of paths, kind of like Hitchhiker's Guide to the Galaxy games were back in the old days, where you play some noise when you encounter something. So that's cool. What else can you do besides just text to speech? And it's like, so we can use something that's really powerful markup called SSML. And not only can you use it to play sounds, you can do other things for it. But here's the skinny on SSML audio clips. They're limited to 90 seconds, 48 kilobit. The file must be hosted from a valid SSL-based source. I use an SSL-based S3 bucket myself, but it has to be a valid certificate too. If the certificate's not valid, it'll give you an error and it won't play. And you can do other commands like pronouncing words. So there's a huge reference for it, but I'll show you some examples here. You can do audio video player support for that. All right, so let's talk about SSML audio real quick. Here's the magic command you need if you're running Linux. It's probably working on Mac too. To encode your file to work with Alexa. I found this is the magic command to make it work because it's pretty picky and it will give you lots of weird, obtuse errors. This command always works. Take your sound file, convert it with that, and then you're good to go. Put it on S3 bucket with SSL web hosting turned on or somewhere else like that. You can play it back. And here's how we do it with SSML. We've got a audio markup. So here's it's from an SS bucket, and then we're going to say there's speech text here, and this will basically play this sound, and then just say whatever this is after it. And you just embed this in with your response. It's nothing fancy. It's just a string of stuff. There's no real SSML builder that I'm aware of. Here we can speak, so we can say things in different ways. We can say say a number as a cardinal number, or you can say it with each digit separately. So sometimes you want to say, 1, 2, 3, 4, 5. Like when you're saying a phone number, right? You wouldn't say 750,000, 2,948 is a phone number. It doesn't make any sense. So this SSML markup helps you say things like that in a way that makes sense. You can also spell out words. I don't know why. That's things we do when we have kids. We spell things out so they don't know what we're saying. But you can do that with Alexa too. All right, so to test this thing, right? You don't have to have a device even. They're cheap, might as well get one. But if you don't have one, you can use the test tab on developer.amazon.com. You can use echosim.io. This was something a third-party developer had made, I think, and Amazon acquired it. And it's just part of the testing suite now. You can do that. Or use any physical device that's tied to your Amazon account. So when you sign on to developer.amazon.com, you're tying that to your Amazon account that you log in with if you're purchasing or shopping. So it all goes to the same place. All the skills are available to anything signed in under that. And you can also share them though. So it has this thing called a beta feature where you can create a beta period and then share that with someone. Say you're doing some consulting work for Alexa skills, and I only want to have the client be able to see a preview of it and get some feedback, right? We'd start a beta period, open that up to certain people at certain email addresses. They can accept that invitation, and now they can access those too. And after the beta period ends, the access goes away. All right, so we looked at one of these examples here, but with Micronaut 1.1 is where the starting release was, or this was added. So if we look here, and this is the Micronaut AWS project on GitHub. And so if you look in the examples directory, you'll find Hello World examples for a Groovy version, install the same thing, Java version, and Kotlin. And we also have another one that's coming. I think it's in just the examples project of Micronaut. Well, we have this Star Wars quiz, which is a more in-depth version that uses all these different APIs. I have to admit, it was kind of hard to find examples using the new API because a lot of documentation out there points to the old stuff. So if you look at my Star Wars demo, which I have here, and inside of here, we've got much richer examples of how to use this stuff, right? So in here, I've got interacting with displays and things like that. And I'll show you an example of this running. But in this case, we actually do more advanced things. We're accessing a DynamoDB database. We're getting session information and session state, which works for short-term interactions. The way that works is it's basically passing a map of data back and forth from the JSON payload. So you can't put large things in it. You can put just small strings or markers or numbers that help you keep the conversation going where you don't want to necessarily go to some external storage and then back again. And it's cool with Micronaut is I can use services and singletons and really divide my code up in a way that doesn't turn into a big mess of spaghetti. So I've got one for the service here as a singleton just for displays, right? Just for doing things related to printing displays or images or dealing with those mundane things in the API. And I've got one here that gives me my answers for the questions, does all the processing for whether when you answer the question, was that the right one that was asked? And then we've also got metrics, right? So don't forget about metrics. There's some built-in metrics now. So when we originally made this, there weren't any, but we have a table in DynamoDB where every time someone does something, it takes a log entry of that and kind of a unique impression of what they did and whether they got the question right or not. So you can kind of use this data to root out, maybe I've got a bad question in there because no one ever gets it right. Maybe there's something wrong with it. Or you can do these things to start recording behaviors of people. How many times they've played the game, right? How many this unique identifier is played so many times. How many people have been using my application. All these things are metrics that help you make your skill better and be constructive and find problems that might exist with it. And then here's, I have a question service. And again, here we're going into building a DynamoDB table. We're querying it. We get the questions. We pick a random question, and we ask them that. And then we can count whether it's been correct, whether we've asked the question before. So we'll keep a little thing in our session, right? It says, we've asked these questions. Don't ask them again. You only get so many questions, so you don't want to do that over and over again or repeat one unless that was intentionally asked. So got all the guts for that in there as well. And then here's our launch request. This is an example of using it again where I can implement the interface instead of using the annotation. And this is what happens on launch. So the first thing that happens when you invoke a skill is the launch service happens. And so in this case, I'm going to do this thing where I'm building up some text, some markup, and to help us with the display and make it look nice. So then I can say, welcome to that. I've got my speech text, my card text. I'm going to get a question. I'm going to store the last question I asked so I don't ask the same one again. Get this map of those asked questions. I'm going to add that. So I'm again putting that in the list so I don't do it next time. And then I'm going to get the text, get a card, and then figure out, oh, is it display supported? If so, I'm going to give you the fancy card. And then I'm going to give you the response for unofficial Star Wars quiz. And then here's the text. I'm going to ask you this thing, number of questions, yada, yada. And then I've got some mundane things here. You can help with ask response, right? Helping build these builders up, whether you have display or not display. So all of those things will help you out. Let me show you the testing options here real quick. I think I've lost mine. There we go. All right, so let's go ahead and test my fancy one out. All right, so we can invoke it by just saying open Micronaut Star Wars quiz, or I can say it. Say it or type it.
Might help. Did you mean unofficial Star Wars trivia?
Let's go back to our invocation test. I have so many skills, I forget the invocation word on half these. Okay, Micronaut Star Wars quiz. All right, so we're going to test it. And you can say open and then the invocation name. I haven't used this one in a while. Let's take it a minute.
Welcome to the unofficial Star Wars quiz. I'm going to ask you 5 questions to test your Star Wars knowledge. Say a repeat question at any time if you need to hear a question again, or
Okay.
say help if you need some help.
So what we've
To
got
answer
here.
a question, just say the number of the answer. Let's get started. Who was the actor
So
inside
here
R2D2?
we've got,
1. David Prowse. 2.
and we're going to tell
Kenny
Alexa
Baker.
to cancel.
3.
I'm tired of the talking.
Michael. Goodbye.
All right, so say goodbye. But look here, we've got our example of our display thing that we built, and it shows you exactly what it looks like. And you can change the resolution of what type of device it would look, how it would look on each one of these devices. You can't actually tell what device they have. It only tells you the capabilities of the device. So you'll have to formulate your display things based on that and handle that appropriately. So I can't tell it's a spot or whatever, because they're always adding new devices. There's no way, they don't want you to hard code to that. Just make your thing adapt to what display capabilities something has. But here's the JSON payload, right? So here's what Alexa sends it. And then here's what our SDK forms as a response. And so we can use this to test. This is definitely your best avenue of testing now. We can also use something echosim.io is another one you can use. And basically you can log in with your Amazon account and just click and talk and use your microphone. So this used to be really kind of junky and minimal, and they've really come a long way. I think it's pretty much all you need to test your skill. Sometimes, though, you'll notice that you had animation on that. So if I try that on a real Echo Show, the real Echo Show doesn't support an animated GIF. So what happens is it's just a static image on the real device, but on a test device, it's actually scrolling and animating. So even the simulator isn't 100%. You may find little quirks like that. Here's how you enable things, right? So by default, all of these things are turned off in this developer console. If we go over here to the build tab, and here we'll see all these things are turned off by default. So if you have code you're deploying and it's using any of these things, you might be scratching your head as to why isn't any of this stuff working? It just pretends it's not there. And that's because you have to turn these on, these little sliders. So if I want to have audio ability or display ability or video ability, or even, and here's where we turn on the gadgets, could do that. And then there are presentation language templates too, which is kind of a non-programming way to make skills. All these things have to be turned on or it just doesn't work. So again, you can just go down here to interfaces and see I could turn these things on. So to make this work with the displays, I had to turn this on. And then if I wanted to do presentation language templates to work, I had to do that, enable that as well. So one tip to keep in mind when you're making these things is you may need to turn them on. All right, so for the visual stuff, when I showed you that example of a visual thing, there's a series of templates that you can use in your code. And there's basically 6 templates. There's one in the middle that's missing. I don't know why. It must have been bad and they took it out. But we've got body template 1, which looks like this. We've got body template 2, which gets a little bit nicer. We've got some fonts going on and a logo and an image. Then we've got body template 3, which kind of just flips the image to the left side versus the right side. And then there's 6 and 7 also available, give more fancy things. There's also templates to do a list of things. So if you want to give them a list, maybe what would have been better actually for this Star Wars quiz is to give them a list, right? And then show the 4 things and say, okay, which of these things are the answer? So I could do that and then, you know, have the answers laid out here. Do that in a list kind of format. So you can do that as well. It works the same way in the API. We got list template 2. We can have a list of things with thumbnails. This is really good for, say, picking videos or picking audio things to play. We can make the Groovy podcast thing real nice with this one, right? Have pictures of each one and what happened on each. And here's what the code looks like to do these things, right? So we basically just create a class for each one of these, and then we create a builder, and then we start building it up. We've got a background image we can add, we can add title, we can add text content. The text content itself can have fonts in it and things like that as well. All right, we just saw it in action, and I just showed you the Star Wars quiz, so we just saw that. And here's some tips for publishing, right? So a human actually looks at these things and tries to run your skill. And if it fails, you want to try to get all your ducks in a row first, right? Because it could take 5 to 7 days, sometimes as low as 3. But to get back around and resubmit your skill and then get it checked again. So try to get everything you possibly can sorted out first before you go through just silly utterances. It will take you forever to get your thing published otherwise. So you must supply an icon, a small one and a big one of exactly that size, nothing other than that size. You must, if you're doing non-Lambda things, i.e. hosting those audio files, or if you're using the Grails plugin and you're hosting it in the Grails app running as a server somewhere, they have to have that valid certificate. It has to be 100% all the way good. You know, can't have any kind of issues whatsoever. It won't work. We'll kick it out. Even though self-signed certs do work in development mode. So you have to keep that in mind. If you're using it in development mode, as long as the host name matches the common name, self-signed certs work in dev mode. But when you go to publish, all of that goes out the window. You need a real, genuine certificate. You must have a privacy policy in terms of use for your skill. So you need to have that as a web page somewhere or something. You can host it from an S3 bucket as a web page if you want. You need to have something there. And again, you must supply proper help at any time. So any interaction, they're going to try to say help. And they're also going to try to trick it and say things that you're not expecting and see if they can make it crash. And if in any situation where they make it crash, you're rejected. And the same goes for stop or cancel. At any point, if the stop or cancel doesn't work, it's rejected. This is one that I fought with personally myself. So it must be clear it doesn't violate any trademark or IP. And they're going to always err on silly things like, for example, a Groovy podcast skill. I had to have Ken Cousin write a letter saying it was okay to use it because we were using RSS feeds off Podbean, and they thought Podbean owned Groovy Podcast, which isn't the case at all, right? They don't own any of those podcasts. They're just a platform. But I had to actually do that because they kept rejecting it, saying I'm not allowed to use property of Podbean for my skill. There's some ways around that. It works sometimes and not always. You can say it's unofficial or a fan version of something. So unofficial Star Wars or fan Star Wars and the title and the name. If you carefully say that everywhere, you might get past it. But sometimes you may have to actually go through this and explain to get past their firewall of copyright. Again, a real person test this. Can take up to 7 days for feedback, so keep that in mind. You know, try to test this thing really well. Maybe have a friend try it out, see if they can break it before you even bother to submit it. You know, you'll have way less iterations and it will take you way less time. Don't ever, if you have like a big conference or something coming up and don't wait till the last minute to try to get this thing published because it probably won't go well for you. Some tips here for making UIs, or not UI really, it's a VI, but try to make sample utterances specific as possible. You know, more sample utterances, the better. Again, misspellings, phonetic things, anything that gives it clues will make your thing better, especially when you're involving weird names of things. Someone that made a Pokemon skill, the names were all weird, right? And those are actually words, so you have to have a lot of variations of sample utterances for how people might say those things for it to actually work at all and not frustrate you. Use those custom slots wherever possible. Always use slots. Use custom slots where you can. And always make sure Alexa responds to a request when prompted. So if you say something and it doesn't say something back, automatic failure, they'll kick it back at you. Again, be specific. Guide users during the prompts. Tell them what to say. Say this or this. Don't give them 5 choices. That's too long of talking. It needs to be really simple, like A or B. And if it's a complicated list of things, then branch it out, right? Say, oh, okay, pick this. Okay, now I started, understand you want pizza. What toppings do you want on your pizza? Would you like meat toppings or veggie toppings? And then branch off to those, right? So you can kind of split it out and not confuse people with choices. Because I guarantee you by the 3rd thing it reads, the person's forgotten what the first one even was. And the only thing that might help them is if they have an Echo Show or some graphic device that at least tells you, gives you a clue, right? You can look at that and remember. Otherwise, people are just going to forget. They're not memorizing these things as they hear it. It's just not how people work. Again, those phonetics and misspellings. Some gotchas that I found. Use number type for numbers. If you don't use that and you have a number, what's going to happen is it's going to spell it out in whatever language they set it in, which, you could hack that together and say, oh, O-N-E means do something. But what if happens when they say it in another language? It's totally going to not work. So make sure to use those types for like numbers or addresses or whatever so that it's consistent. They do have an Amazon literal type. They've threatened to get rid of this since they created the Echo, and they never really did because there's just so many corner cases where you give it a speech pattern and it gives you one back, and there's no and parameters. Slots don't really work all that well when the slots are variable. Those are really tricky to do though, and I don't recommend using it because again, they say they could go away at any time. Some invocations for things don't work. Hello, Amazon Echo. I've not had a lot of good luck using Grails as the invocation word because it just has a hard time understanding it. Remember, when you're saying invocation word, the local Alexa at your house needs to be able to understand it. And it's way less intelligent than the cloud stuff. So if the wake up word or invocation is bad, then it could be an issue. Or it conflicts with the wake up word, I should say. Again, self-signed certs. When you're doing development mode, you can do this, but make sure the common name matches the host name or it doesn't work. You don't really need to worry about this though when you're running Lambdas, thankfully. That actually just removes a layer of complication. Unless you're running API gateway and want to make it part of something bigger. And again, use SSML audio, follow those tips. It's very picky about where those audio files are hosted. And again, audio content must always be streamed via SSL, so there's no exceptions to that. You can't just have a non-SSL HTTP thing. It's not going to let it work. All right, so I've got some sources here. I've got some GitHub examples and all those things here you can go to for Micronaut and the Star Wars quiz, how to run your browsers and test them. The API migration guide is the best document I've found so far about how to read version 2 of the API. And special thanks to Graham and Lee and Benoit for helping me out in the beginnings of this thing back when I started with Grails. All right, Jen, I'm gonna hand it over to you.
Okay, thank you, Brian, for your time today for this webinar. It was super interesting. And there haven't been any chat questions that have come through for the Q&A. So we will open that up now. If you have any questions for Ryan, please go ahead and put those in the chat. We will hang out here for the next 5 minutes or so. If anybody has any questions, please go ahead and put those there. And thank you for joining us.
Yeah, thank you.
Okay, Ryan, we did get a question here. So how do you implement a yes/no type query? So for example, I think that you want to end the game. Would you like to end the game? Was the question.
Okay, yeah. So basically what we could do is we could have an intent, like an answer intent here, right? So in this case, I've got a list of answers. I could make this a yes/no question. And I think there's actually a yes, no type. For a Boolean, maybe. Let's see. Well, we can just make a list of answers. What we could do is to change this around is we could actually go into our list of answers here under our slot type. And I could basically just change this to yes, no, and I could do that, right? And that way it could become a yes, no question. I'd just delete all the other options. That's one way you could do it. And just, get rid of all these other choices here. So that's one way you could make a yes, no question on that. Do you have any,
Thank you.
have any more?
That looks like it's it so far.
Great. Well, thank you everybody who attended. And if you're watching this after the fact, you can always try to hit me up on Twitter at Ryan Vanderwerf, and I'll try to help you out. Or always hit up OCI. Kind folks there will do anything to help you if you need help developing these things or need any kind of assistance with technical issues around Micronaut, Grails, or Groovy, or these Alexa skills and making them. I'm happy to provide services to you for whatever your needs may be. Again,
Yes.
thank you everyone for attending. Have a great day.